class. We won't use it like initially, but we will run into it when we use strings, okay? The char or char data type. So let me go here and go here. Okay, so again, like for example, if we have the main program and then in main we have this code, character variable name is letter, and say we have like the letter A. Like how do we map this onto main? So we have stack. And this is just to show you how characters are stored in memory. Okay, so we know by now that if that's main, then main has to get a block of memory. All of these are for variables that main has. For us, we're just assuming that letter is the only variable there. That'll go here. Okay, but we want to understand how it would look in in a 1 byte, 2, 3, 4, 5, 6, 7 block of memory, assuming like we had a magnifying glass and we could like zoom into it, right? So let me go here, and in Google, if you do ASCII tables search, then the first hit is usually the ASCIItable.com. So we go here and we go and look for the letter A right here. So its decimal value is 97. Okay, so and then for capital A it will be 65, right? So maybe we should just do capital A, right? Mess around with it. So we have 1, 2, 4, 8, 16, 32, 64, and 128. So we're like, how does the letter A, the capital A, look in memory? So this has value 65, so meaning we have to make 65 with ones and zeros. So for 65 we need what? 64 and 1, right? That'll net us 65. So we can say, okay, I know I need 1, not needed, not needed, not needed, not needed, not needed, needed, not needed. So that's how a character is stored in memory. I bring this up because like you might be trying to compare like values, like character to character, and understanding this, like you'll know that like the letter capital A is less than the lower A, right? Not like as we see it, like we see the capital A to us, it's like, hey, that's larger than A, but the computer will compare values 65 and value 97. Okay, so that's why I bring this up. For this class, this is sufficient. We're like, this is letter A, and notice here it's 1 byte. 1, 2, 3, 4, 5, 6, 7, 8 bits. 8 bits is 1 byte. And that's how a character is stored in memory. And we can go ahead and create an example for this one. So we go to CodeSpace. Actually, I went too fast there, right? So I'll pause here and then I'll ask if there's questions. So any questions here? This is the convention we'll use in this class. We'll just be like, okay, this is 1 byte, and we'll just put the letter A, and notice here we're just putting the arrow to like help us trace the code. Okay, so now since there's no questions, I can go and create an example that explains what I just, or that shows us what I just said, right? That if we compare values, or if we show values, then we're like, is that really true or not? I mean, did they build that into the computer, program it? Well, there's one way to find out, and that's with an example. So we go here, and we jump to character. And we go to character.h, and here we write a function that returns an integer, right? Int function. It returns a number, and we name it get character as key value, char parameter or character parameter. So we'll say that, and we'll say letter. Oops. And we put a semicolon only in the header. Now we can jump back to the character. Okay. Oops. That doesn't go there. My fault. Okay. We go here. Let's always remember to include the header file. And now we can go here, Control V, open close curly brace, return the ASCII value of the character. I don't need function. Sorry, I copied it before I fixed that issue. Okay. So if we go back and look at this example here, we can conclude that the letter A is stored as a number. Like the letter A is stored as a number on the computer. So if I save the letter A onto the computer, then the computer is seeing some number. And I say that because we are feeding our function a character, and then we want a number back. So is it as easy as saying return letter? And that'll give us a decimal value, or the ASCII value of whatever letter we send in, or character. Yep. Let me change this. I think we put CH for character, right? Because it's not a letter. It cannot just be a letter. It can be any character. And if we go see, notice like these are characters too. And if I put letter, it's kind of misleading. So I have to name my variables accordingly, give them meaningful names that fits the context. So we go here. I'll just put CH for some character. And the answer is yes. Like, if I send in a character into a function and I return an integer, then the computer will return its integer representation, because that's how it's storing it in memory to begin with, right? So we can go and test that. We'll go to test case. And if we scroll down here, let's see here. We'll say test case, test character to integer conversion. That's what we're going to test really, right? I mean, is it really that easy? So we go here and we create one assertion, require. Oops. I don't know what sequence I hit. Okay. Require. Down, enter. So I'm saying that if I call get char ASCII value, it should give me some number back. But I'm not using the char header here, so I have to include it. Otherwise, the programming language will not know what I'm talking about. So I have to say, hey, bring in char.h. So now it'll know what I'm talking about when I want to use my get character ASCII function. Control space, enter. And what is Joe? Okay, Joe. Test case, string test. Let me see here. String test ASCII values Joe chars are equal to 74, 111, and 101. Okay, we'll do one at a time. So we'll say is J equal to 74. That's the first step. And then we'll say if we feed in lowercase o, will that return 111 to us? And if we use E, will that generate 101 for us. So we have JOE, right? And then we can run this piece of code. So we go to our test, right click, and run in terminal. Make sure you are in CMake, right? You have to be in CMake to have the run in terminal option. Okay, so we're green, meaning we are good. So let me explain what I did, right? So it ran the program, and if you do up arrow here, hopefully up arrow, froze, happened. Up arrow, maybe my keyboard stopped. Okay, up arrow, no, that up arrow doesn't work. Okay, let me run it again, sorry, I'm not sure what happened. So run in terminal. Okay, I make sure I'm on the terminal. Up arrow, space, -s, enter, and that'll give us detail. And notice here it's saying you said that if you use get char ASCII value with capital J, it should be 74. That's the case. And with O, it should be 111. That's the case. And with E, it should be 101. That's the case. So let's look at O. So we go up here and we're like, okay, let's look for the letter O. 111. And let's look for E, 101. Let's look for capital J, 74. So now, like the diagram that I showed you, then it is accurate, right? So that's how characters would be stored in memory. Question here? Okay, so no questions. So